All right, ladies and gentlemen, for this presentation we're going to talk about some of the variety that can be found in these atomic structures that we've been discussing. And we're also going to talk a little bit about some of the details that go along with the electron cloud. So the first thing that we want to discuss is something that is referred to as isotopes. Now, it's important for you to understand that isotopes are still an atom. So if I have an isotope of lithium, like I have right here, it's still lithium, all right? It's just that isotopes can sometimes give an atom new properties. So they can change the properties of the atom. All right, now typically that's mass or density, or occasionally isotopes can actually turn something radioactive, and that's stuff that we'll discuss a little bit later on. Now the key about isotopes is it is varying the number of neutrons. Okay, so you notice here in this first example I have lithium. Now here lithium has 1, 2, 3 neutrons, 1, 2, 3 protons. So what you'll notice here is this number is the protons in lithium, and this number is the mass. Okay? Now if we go to this example, right here, I have 1, 2, 3, 4 neutrons, and 1, 2, 3 protons. And so this number is the protons, and this number is the mass. Hopefully you're seeing a pattern, because this is a notation that we use for isotopes, where we put the mass number as a superscript on the upper left, and the number of protons on the bottom right. Or I'm sorry, on the bottom left. And you could see this over here again. In this example, I have 1, 2, 3, 4, 5 neutrons, and 1, 2, 3 protons. So here I have the number of protons, and here I have the mass. Now it's very important for you to notice the number of protons never changed. For isotope 1, it was 3. For isotope 2, it was 3. For isotope 3, it was 3. The number of protons did not change. That's a big deal. The number of protons tells you the atom. That's something that you cannot get away from. Now, what you will notice is that each of these is different isotopes of lithium. The mass changed for each isotope. And so that means the number of neutrons changed. Let's take a look at down here. So here's another notation. See this right here? Carbon with a 12. That, again, is the mass. Carbon 14, again, that's the mass. This is another type of notation where you put the element symbol, a dash, and then the mass. Now what you'll notice here is, here I have 1, 2, 3, 4, 5, 6 neutrons. I'm sorry. The pluses should tell me that that's 6 protons. And over here I have 6 neutrons. 6 plus 6 is 12. Now here you'll notice 1, 2, 3, 4, 5, 6 protons. The number of protons did not change. But I have 1, 2, 3, 4, 5, 6, 7, 8 neutrons. And so there the number of neutrons did change. And so the real heart of this is isotopes are versions of an element with different neutrons. Okay? That's really the heart of what isotopes are. Now, this is going to be a subtle thing, but it's going to be very important. Some isotopes are more common than others. Okay? Some isotopes are more common than others. That's why the mass number is decimals. The decimals represent a percent average. So what you're actually seeing is sort of a mean, like the most common isotopes are average together with the least common isotopes, and that's why you have a decimal. All right? It's because it's the mean of the isotopes. And when we round, generally what we're doing is rounding to the most common. All right? So when we round, it gives us the most common isotope. All right, so that's isotopes. Isotopes are when you vary neutrons. Sometimes they give the element a slightly different properties. Mostly it's just a change in the mass, okay? Now, in addition to this, what I want to talk a little bit about is the location of electrons in the electron cloud. Now, the electron cloud is not as simple as just space where electrons exist. It actually has specific locations. And we call those things energy levels or electron shells. And we're actually going to get into some details here with this stuff as we move forward. But what you'll see here is, usually when we draw a circle like I'm drawing right here on the screen, we place an electron there. That's one energy level. And you'll notice down here, I have one energy level. I have 2 electrons in it. Then I have a second energy level. Now, we're going to get into some of the details here, but the first energy level always holds 2. The second energy level always holds 8. The third energy level always holds 8. We refer to this as the law of octet, because it holds 8. Now, energy levels beyond that actually hold more, but we're going to get into a little more detail with that. What's really important for you to remember here is the first level holds 2, the second level holds 8, the third level holds 8. Okay? And so when you go over here, you can see this is an element with 2 electrons, one on either side. And what's important about this is this element has a full outer shell. See how there's one energy level, and that energy level has 2? And you can see down here, that holds 2. So it's full. It holds 2, it has 2, it's full. It holds 2, it has 2, it's full. Now you look down here. I got 1, 2. It's the same as here. So that energy level's full. But then when I go here, to this second level, the lithium over here only has 1. It's not full. But this neon over here has 1, 2, 3, 4, 5, 6, 7, 8. And you'll notice right here, that's how many it holds. So it has a full outer shell. That means it doesn't react. All right? Full outer shell is a key idea when it comes to chemistry. And we actually refer to the outer shell as the valence shell. Okay? And that's going to be an idea that we continue to reference as we move forward. So the reason we went into that is because there's another way that you can vary electrons. And that's by creating something called an ion. Now you notice at this diagram at the top, there's two types of ions. You have positive ions, and you have negative ions. You can see the plus right there and the minus right there. Basically what happens is you start with an atom. You see the atom in the middle. If you lose electrons, it becomes a positive ion. If you gain electrons, it becomes a negative ion. That's where people become confused. Because when you're gaining electrons, you're gaining extra negative charges. That's why it becomes negative. But the reason that ions become positive when you lose electrons is because you can't change the protons. And since you can't change the protons, that means that there's more protons. There's now less electrons because you lost them. And since there's more protons and less electrons, now the atom has more positive charges than negative charges. So take a look over here, right? So sodium has an atomic number of 11, which means it has 11 positive charges. Well, we know that elements start with the same number of electrons as they do protons. So that means that this would have 11 negative charges. Overall charge, 0. But see how this loses an outer electron? So now, sodium has 11 positive charges, because that can't change. The number of protons cannot change. But since it lost an outer electron, it now only has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it has 10 negative charges. Overall, that means I have 1 extra positive charge. And that's why sodium here is a positive ion. Let's take a look at another example. So here I have oxygen, right? Now you'll notice that oxygen has 8 protons, so that means that oxygen has 8 positive charges because it's oxygen. And in this case, it's got 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 negative charges because it has 8 electrons. That is the case because atoms always begin with the same number of electrons as protons. Overall, that's a 0 charge. Now over here, I have an ion. So it's oxygen. So it still has 8 protons, because if it doesn't have 8 protons, it is not oxygen. Those 8 protons give me 8 positive charges. You'll notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, which means that I now have 2 extra negative charges, and that's why it's a -2 ion. So just to review, we've got electrons that can be lost or gained to create ions, neutrons that can be lost or gained to create isotopes, and the electrons within the electron shell, the electron cloud rather, exist in shells or energy levels. All right, that is our presentation for today.